Welcome dear student, welcome to my channel Talking Physics with Piyas Sarkar. So today we know some interesting topic about a body freely falling on the earth surface from a small distance, which is called motion under gravity. So in the previous lecture we can know about one dimensional motion. Motion under gravity is also a special case of one dimensional motion. But there are certain difference between the motion of a particle in horizontal plane and motion in a particle in vertical plane. So motion under gravity is specifically a special case, that is the motion of particle under the gravity. Here a particle fall from a small height from the earth surface. If this is ground or earth surface, then the particle fall or particle can be thrown up from the earth surface. So in general we can know the equation of motion as V equal to ut plus half at square. Number 2 is V square is equal to u square plus twice as. Number 3 is s is equal to ut plus half at square, and number 4th is distance covered in nth second, that is Sn equal to u plus half of a twice n minus 1, where v is final velocity, u is initial velocity. As we know, s is distance covered in time t and Sn is the nth second distance covered in nth second. But in case of the motion under gravity, we can note out some important fact, which if we do not follow this rule, we will have certainly do some mistake. So in this case we can take at first s equal to not the total distance covered, s equal to the displacement, we can say it as net displacement. It is not the total distance, but it is say net displacement if s and v, that is the velocity, or u are in same direction, then they have same sign. If the displacement, direction of displacement and direction of velocity are in the same direction, then they have the same sign, otherwise they have opposite sign. We can do this point while doing our numericals. Number 2, when the body is thrown upward, its velocity becomes decrease as acceleration due to gravity, that is the value of g is in the downward direction. So when the body is thrown upward, we can take the value of g as minus g. But when the body is falling downward, we can take this is as plus g. So the total height, maximum height reach is h is equal to u square divided by twice g. Time of ascent equal to time of descent is equal to u by g. Therefore the total time is twice u by g, and the velocity we can write it here, as my board is very small. The velocity Number 6 point is velocity before reaching ground v is equal to root under twice gh. So this point we should remember so that we do not do any mistake. The calculation is slightly different from the dimension from the motion in horizontal plane. Okay, so let us take with some example. Write down in your copy, this is very important. Now we shall go with some numerical problem which is very important and students often mistake it by using wrong sign of convention. So we can do with my first numerical, which is a ball is thrown vertically upwards with a velocity of 20 meter per second from the top of a building. Suppose this is a building. A ball, someone standing here and his ball is thrown vertically upwards with a velocity, that is initial velocity equal to 20 meter per second. The height of the point from where the ball is thrown is 25 meter from the ground. We can take it, this is ground, so the height of projection h equal to 25 meter. So we have to calculate how height will the ball rise, that is how height the ball is rise, how height the ball rises. Number 2, how long will it take before the ball hits the ground? How long it take before the balls hits the ground, So we have to do this numerical. So here the sign convention takes an important role. We can always take u as positive for upward motion, and we can only consider the starting point. Whatever be the mathematics, whatever be the numerical, we can always consider from the starting point. Suppose this is the starting point and u is taken vertically upwards, that is u is plus 20. But here h is taken as minus 25 because h is, we can say it earlier that it is net displacement, not the distance covered. We can know the difference between distance and displacement. If you do not know, please check my channel and watch one-dimensional motion in my channel, that is Talking Physics with Piasek. Minus 25 meter is the net displacement. Now displacement is from initial to final, from P to Q point. So the direction of displacement is downward and the direction of velocity is upward. So if we take the velocity positive, then the sign of displacement becomes negative. So we can get how height the ball is rise. This height is not h because the ball will rise from this point to maximum height. So if we take it how height, that is it is taken to be capital H. So this height is the total displacement, that is the distance of the point from the ground, but this height is from the point of projection to the maximum height. So we can do it as this is vertically, so g equal to minus 10 meter per second square. So from the equation v square equal to u square plus 2gh, we can show that maximum height, in the case of maximum height, the ball will stay rest at that point, at maximum point. So we can take at v equal to 0, u equal to plus 20 square plus 2 into g equal to minus 10 into, we can take it the value of h. Here h is not negative, we can say that capital H and small h are totally different. So we can say that h equal to minus 400 divided by minus 20, that is plus 20 meter. So we can find out the first answer, how height the ball is rise, it is plus 20 meter. Next we can go that how long it take before the balls hit the ground. In this case we can take the net displacement. So we know that s equal to ut plus half at square, but here s equal to minus h, that is minus 25 equal to plus 20 into t plus half into minus g, that is minus 10. We can write the value into t square. We can find out the value of t. We can find out the value of t that is minus 25 equal to 20t minus 5t square, or we can write it as 5t square plus 20t plus, sorry, minus 5t square plus 20t plus 25 equals 5 equal to 0. So we can get t plus 1 and t minus 5 equal to 0. So the value of t will be minus 1 and 5, but this is not possible because time cannot be negative. So we can get the value of t equal to 5 seconds. I hope you understand the total problem, and this is the full concept. Please do not confuse between the capital H and small h, because the capital H is the maximum height and small h is the net displacement, and is taken always negative in case of upward direction of object. Okay. So we next go with the another problem which is very important for your upcoming exam. The viewers, if you do not understand any topic or it is tough to understand, please comment me in YouTube comment box so that I can do it for you as my level best. So next we go with the another problem. This is known as balloon stone problem or balloon food packet problem. The problem is a stone is dropped from a balloon rising upwards with a velocity of 16 meter per second. A balloon if this is balloon, I draw very bad but you can have to understand that as a balloon because there is no any other scope for you. So a balloon is going upward with a velocity of 16 meter per second, and then a stone is dropped. The stone reaches the ground at 4 seconds. If this is ground, then the stone reaches the ground at t equal to 4 seconds. We have to calculate the height of the balloon when the stone was dropped. We have to calculate the height of the balloon, that is the net displacement. Here we can consider two cases. One is what will occur at starting point, and other is when the balloon drop the stone, the magnitude and direction of initial velocity, that is u, will be same, because as the balloon is going upwards, if we put a stone, then it first go upwards, then it down to vertically downwards. So as per starting point, the velocity of u is plus 60. So again from the equation, s equal to ut plus half gt square. Here g is not to be said as 10 meter per second square, so we can take it the value of g as 9.8. If it is not be said, then we can must take g equal to 9.8. So this is another case of upward motion, so we can take the value of g as minus 9.8 per meter square. So what will be the case of h? S is the next displacement, as again the velocity and displacement has opposite sign, so here we can write s equal to minus h. So minus h equal to ut, that is 16 into 4 plus half into minus 9.8 into 4 square. So minus h is equal to 64 minus 16 into 9.8 by 2. We can get it as 78.4. 78.4. If you do it in your calculator, you can get it as 78.4. So we can get it as minus 14.4. A minus minus cancel, so you can get the value of h equal to plus 14.4 meter. So you can get that the 14.4 meter is the distance of the balloon from the ground when the stone was dropped. So in this way, you can do any type of numerical. If the stone would not be go upwards, if someone fall from a height, the balloon or the stone in downward direction, so the u will be then negative and g will be positive then, okay, because, and again here the displacement will be positive because the direction of u is in downward direction, the direction of h is also downward direction, and g will be positive for downward particle, okay. So in this way we can do any type of numericals. So today we learn about the motion of the object under gravitational force. In the next day we will do with some numericals with some different type of graphs and their slope and problem related to graphical points, okay. So for today, thank you, keep watching my video and stay tuned for the next upcoming a lot of interesting videos. Thank you.